All right, good day everybody. Today we are talking about domain and range. So the set of allowed input values is called the domain. We're talking x's, we're talking inputs to the function. When we talk about f of x, the possible values that we can put there is our domain. Conventionally, that is usually, we write it after the rule using set notation or inequalities. For instance, if f of x equals the square root of x, a lot of times you'll see the inequality that x has to be greater than or equal to 0. That statement right there is the domain. Another way to say x is greater than 0, greater than or equal to 0, would be with the notation 0, infinity, square bracket closed in like that means including 0. This parenthesis, or you'll see it written as a backward square bracket, means we don't include this endpoint. On a number line, it would look like this. Solid dot with an arrow going that way off to infinity. We could say the interval from 0 to 3, on a number line, it would look like this. 0 with a closed dot, 3 with an open dot, shaded in the middle. So that's what we're talking about with domain. Now, some hints, some suggestions for you. The domain oftentimes gets changed from all real numbers because we can't divide by 0, we can't square root negatives, and we can't take logarithms of negative numbers or zeros. Those create restrictions on our domain. For instance, for the function f of x equals 3x minus 5, that's a line. We'd say that this domain is x is an element of the real numbers. So once we start dividing by x or square rooting x or taking the log of x, this domain gets restricted to inequalities and intervals such as those. The set of possible outputs is called the range. We're talking y values on a graph. The easiest way to read this is by looking at a graph. Our range will depend on the domain, so please be conscious of that. So here we go. Some examples. Sketch the graph of f of x equals x plus 1 over the domain. X is an element of the reals, and x has to be greater than 1. So, x plus 1, that is a line that has a y-intercept of 1 and a slope of positive 1. So this line looks like that. But it also says that x has to be greater than 1. So that means that x cannot be less than 1. So this part of the line has to go away. And because it's less than 1, we change this endpoint to an open dot like that. There is our graph. Sketch the graph of it over the domain. X is an element of the integers. So here we go at the integers. That means when x is 0, y is 1. X is 1, y would be 2. X is 2, y would be 3. And our graph looks like this. We do not connect the points because the points in between these come from fractional values of x, not from x's that are an element of the integers. This z stands for the set of integers. This r stands for the set of real numbers. What is the largest possible domain? Well, we look at this. So our function is named h, and another way to look at this is h of x equals 1 over x minus 2 plus square root x plus 3. Well, what can't x be? Well, x can't be 2. We know that. And we know that this can't be negative, the thing under the square root. So let's also say, okay, x plus 3, that has to stay greater than or equal to 0 for this function to work. If x was negative 4, or if x was negative 4, then negative 4 plus 3 is not greater than 0. We wouldn't be able to square root that. So let's subtract 3. Let's solve this little inequality. X has to be greater than or equal to negative 3. So x has to be greater than or equal to 3. So using interval notation, negative 3, comma 2, union 2 to infinity. Or we could say negative 3 comma 2 parenthesis, union, parenthesis 2 comma infinity. These are open intervals, which means we're not including the 2. Or we could say x has to be greater than or equal to negative 3, comma, x doesn't equal 2. All three of these statements mean the same thing. On a number line, it would look like this. Here's our negative 3, including that. Here's our 2. We don't include that, but we include everything else that's bigger than negative 3. Find the range of f of x equals x squared plus 3 if the domain is x being all real numbers. So I'm going to go to my graphing calculator. Here we go, x squared plus 3. So I want the range if x is all real numbers. So as x goes this way, as x gets more and more positive, this graph is going up, 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 up forever. Up, up, up forever. But it doesn't go down forever. It stops right there. Our range for when x is a set of the real numbers, x is an element of the real numbers, would be f of x has to be greater than or equal to 3. Or we could say y is an element of 3 to infinity. Now, how does that change if our domain is x greater than 2? So what's that look like on our graph? Well, here's 2, 1, 2. Boom. That means this is really the only part of the graph we care about. The rest of this, it doesn't matter. All of that we're ignoring. That's not a part of this function anymore. We're starting at x equals 2. So what is that output? Well, 2 squared plus 3, that's 7. This point right here, this open interval, this open point is 2 comma 7. So our y values are getting bigger after that. So our range is going to be y is an element of the open interval from 7 to infinity. And there we go. A lot of domain and range can be seen just from your graph. So it's a really good idea to be looking at pictures. That's all for today, ladies and gentlemen.